Hello everyone and welcome to the channel. Decision tree, random forest, and gradient boosting. All of them are types of supervised machine learning algorithms. In this video, we will try to explain the concept behind each one of them and what are the advantages and disadvantages for each. Decision tree. As the name indicates, it reflects the structure of a tree that is upside down, where the root represents the entire dataset, and this dataset will be splitted and flowed through the different elements of the tree in the form of yes or no questions until we get to the leaf, which is the output. Let's take an example. Let's say I have a dataset of students' applications to the medical school, and I have information like their GPA, their scores in the admission exam, and so on. We will start with all applications as the entire dataset. And then the first question will be, what is the GPA? Is it more than 3.5? If the answer is yes, then the next question is, what is the score in the verbal admission exam? Is it more than 535? If the answer is yes, then the applicants get invited to the interview. If the answer is no, the application gets rejected. On the other side, if the GPA is less than 3.5, then the next question is, what is the score in the verbal admission exam? Is it more than 555? And now the requirement is a little bit higher because the GPA is less. If the answer is no, then the applicants get rejected. And if the answer is yes, then the next question is, what is the score in the quantitative admission exam? Is it more than 655? If the answer is yes, then the applicants get invited to the interview. If the answer is no, then the application gets rejected. So this is decision tree, and this is how the algorithm works from the entire data set, which is flowed in the form of series of yes or no questions until we get to the final decision. When we build a decision tree, the first thing we need to do is to set up the parameters for the tree, like the maximum depth of the tree and other parameters. Next, we need to train the tree or the algorithm. If you go back to our students' applications example, we have to give the applications to the algorithm or the tree and to tell the algorithm that these applications were selected and these applications were rejected. That means we give input and we give output at the same time. And now the tree or the algorithm will learn from this input and output and will understand that, okay, when the GPA was this and the admission score was this, the application was rejected. And when the GPA was this and the scores in the admission exam was this, the application is accepted. And now the algorithm will find the right configuration for the tree to get to the right answers or the right decisions. And then we can further test and evaluate our algorithm by giving the algorithm another dataset of applications without telling the algorithm which applications were selected and which applications were rejected. And then we ask the algorithm to classify or to predict for us which applications to select and which applications to reject. And then we evaluate how well the model is doing with selecting the right applications or rejecting the right applications. And if the accuracy is high and the algorithm is doing well, then the next step would be to take it into action and deploy this model. Advantages of decision tree: it is easy to visualize and easy to interpret. For example, if an application gets accepted or rejected, I can visualize the tree and understand why this one was accepted and why this one was rejected, maybe because of the GPA or the score in the admission exam and so on. On the other hand, the disadvantages: there is a risk of overfitting and it is very sensitive to change in the dataset. This means the algorithm can work very well on the training dataset, but when you bring it to reality and there is a small changes in the dataset, it might not provide reliable results. So this was in brief decision tree, and now let's discuss about random forest. Random forest. As the name indicates, it's about building multiple trees, training them individually, and getting a vote from each one in order to get to the final decision. It is more accurate and robust than a single tree, but it is difficult to interpret and visualize, especially when we have many trees or multiple trees. It is difficult to explain why this was the final decision. Also, it takes more time to train and to get a decision than a single tree. And lastly, gradient boosting. Gradient boosting is also about building multiple trees but connected in a sequential way so that each tree corrects the error of the previous one. The idea is that if you connect multiple weak trees in a sequential way, correcting each other, you end up having one strong algorithm called gradient boosting. It is very accurate and very robust, but also very slow compared to random forest or a single tree. So this is the end of this video. Thank you very much.